The given question is expand unique paths. So we are given an input matrix which has arrays of arrays. So as you can see here, the input is an array of arrays. We will be given the starting point as 0, 0, and we need to find the number of ways to reach the goal. The finish point will be the last block of the entire matrix. So we need to find the number of ways the start can go from the path choosing over here to here, based upon the condition that the start can move in only two directions. It can move either below or either right side. As given here, the robot tries to move to the bottom right corner. It can either move either down or right at any point in time. So it can only move down or right at any point of time. So for this, we need to use a dynamic programming approach, like it is a 2D-DP. So what we will be doing is, we will so if the point of start is over here, we can choose either here or here, right? Similarly, if we are here, we can choose here or here. Similarly, if we are here, we can choose this or this. So I can say that at a point, the number of possible ways is sum of the right side and sum of the bottom side. So yeah, suppose x is over here and y is over here and z is over here. So x can go to y and z. Now number of ways from x will be equal to number of ways at y plus number of ways at z. Using this, it is like similar like dp of I j equal to dp of I plus 1 j plus dp of j dp of I j plus 1. Yeah, so this is the main dp signature we need to follow for this problem. So how we will have the initial values? So we will be starting from the last finish point. So from last finish point, if we check, from this point we can reach only with one way, because we can only go right or bottom. If there is no bottom, then we need to only go to right, so it will be only one. Similarly, for every block which is the last row will be one. Similarly, for the every column which is the last column will be one, where there is only one way to go bottom, where there is only way to go right side. So we will first initialize that. So let's initialize the dp at first. So dp will be, I'm just initializing it with 0. So I'm initializing with 0 with m rows, n rows, n columns, and it will have m rows. So I need to initialize the last row with ones and the last column with ones. For I in m, for j and length of n, if so what condition would do? If I'm equal, if I is equal to m minus 1, I will be just filling the dp with And if j is equal to n minus 1, also I will just initialize the dp with 1. So after initialization, we need to memorize the dp, or we need to build up the cache from here, this point, this point, as all these values are zeros right now, and this is 1, this is 1, and this entire row is 1. We need to start from here, as if we start from here, it will add these values, and similarly we will iterate through here. Similarly it will get the sum from these two. Similarly it will get sum from these two, and it will go from here, and again it will come from here, and again it goes to here. So for iterating backwards, I will just write two for loops for I in range m2 m minus 2 comma minus 1 comma minus 1, for j in range of n minus 2 comma minus 1 comma minus 1. So I'll just use the signature which we have written. Yeah, so after completely storing the cache, we just return the first value, as it has the number of ways. Yeah, so it's accepted. Yeah, it's got accepted. So in this way we'll solve the problem. Unique paths, the complexity would be worst complexity would be big O of m into n.